Morning. Morning. You guys there?
Yeah.
Present.
Hello.
Hello. I think that's where we left off, right there. So you guys can look at that while we're waiting to begin. The sixth graders are killing me with the way that they're submitting their tests. So it's been taking me so long to get through. Some of the tests take me 10, 15 minutes to grade one student's test because, you know, they're not, I don't know, I haven't even looked at yours. I could be talking to you guys and some of you doing the same thing. I don't know. But it's, you know, I'll try to read the document and it'll be so washed out in light that you can barely see it. It was out of focus. Pages turned upside down, submitted as 6 documents out of order and upside down or turned sideways. And in Schoology, I can't flip it, so I have to actually open it up as a PDF, each one, flip it, just so I could grade it. And then the work, it'll be out of order, so then I open the wrong one. And then there's no rationale to what order, so I'm trying to guess where number 1 is. You know, they didn't start with number 1, so I'm clicking down each document, opening them up. It's just, it's torture. It really is torture. It's a form of torture. Not as bad as others, but still, it created some mental anguish.
Worst type of torture, huh? Wasting time. When you know you're wasting your time.
Actually, for me, inefficiency, it's I don't know, it's just damaging to my brain. I can't handle it.
There are definitely worse types of torture, though.
Yeah, I mean, but it's all a matter of perspective. Everybody has their own things that get to them, whereas something that would be torture for one would not be for another.
I feel like having your foot dipped in molten lead and having to wear it around for the rest of your life is like
I'm not equating it to physical torture. I'm just saying that, you know, I'm trying to do administrative stuff for the school. I'm trying to create new lessons. Normally, I have all these lessons done for geometry, and we finish right at the end. So I'm doing lesson creation now, which is an added task. And then the tests take 15 minutes for one student sometimes to grade because they don't look at it first. That's all that all you would have to do, each individual would just have to look at what they're about to submit and see if it's reasonable. Anybody who's reasonable will see, oh, I can't actually see the document, but they just take the picture and send without looking at it. So that's why, you know, next time we take a quiz or a test or whatever we're going to take, you guys have to proofread what you're about to submit to me, and it needs to be in one document. You guys should practice now, way in advance. Download Cam Scanner on your phone. I strongly recommend Cam Scanner, unless you already have another method that works great. But one document, you take as many these lessons were taken on Cam Scanner. Some of them are like 17 pages long. It's all one document, one PDF. Okay? So if I can do it, you guys can do it. I don't have some education in technology that exceeds your education in technology. So.
Well, for some reason, Mr. Sorry to interrupt, Mr. Ostell, but if my test hasn't been submitted on Cam Scanner, it's because the app was not serving well on my phone. I don't understand what the issue was, but I had to take a photo because we were only 10 minutes away from the submission date.
I haven't seen any of the geometry students' Chapter 12 tests yet. I'm just trying to finish up that second class of 6th graders. And
That's how long it's taking?
yeah, every day I try to do as much as, remember, I'm homeschooling my children too. And you know, right now I'm teaching, my wife is with the kids and she works full time. So she, as soon as I'm done with my 6th grade group at 11:30 is when office hours ends, she's already done the whole morning with them. So I have an obligation to my children, and I want to educate them because they're not in school. So, and they're only, you know, my son just turned 6, May 2nd. My daughter's 4. So they can't, I can't just give them an assignment to do off on their own. They won't do it. You have to sit there with them. So I'm trying to teach them how to read and how to do math and stuff like that. And so there are only so many hours in the day. And then I got to do lesson creation. And then I got to help with the matrix for next year, for your schedule of classes next year and what's going to be available and new teachers that we're having to hire. I'm interviewing them. So, you know, there's a lot. So then when I finally get to grade, I get this little bit of time to grade, and then it takes 15 minutes to grade one paper. You know, you spend an hour and you've only graded 4 or 5 students, and you just feel like you're not getting anywhere. That's kind of how it is. So it's something that I'm actually spending the time now, even though we're into class time, as an investment of my time to try to communicate, because I don't expect, or, you know, students to know on my end what that looks like. So I'm just trying to provide a little perspective so that you know how important it is to submit for the next time. It's too late for the last time, but for the next time, to submit a pristine document, a single pristine document that's not on its side, it's not upside down. And that means that I don't have to open it as a PDF. I can just immediately start going down the answer key, going yes, 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 no. Then I look at the work. Oh, this is why it's no. Okay, move on, boom, 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 boom. 60 seconds, I'm on to the next one.
I use HP Smart.
You know,
It's
and then
really helpful.
And that hour of time that I have, I can maybe get through a class and a half or 2 classes, so that I can get through all 6 of my classes in a matter of a few days instead of weeks.
Well, I sympathize with your cause, Mr. Rosenthal.
Well, I appreciate that. Now I would rather the sympathy go towards future action. All right? Now, without further ado, does anybody need to see any of these from yesterday before we move on?
Wait, can I just see 14 for like a little bit?
Sure.
Mr. Rosenthal, I'm pretty sure the collage function on CanScanner is a premium feature.
You don't need it. I thought that too. I really thought when I first got Cam Scanner, oh, you need a collage. You just disregard that. You do not need all of these lessons that you see. These are not collage. These are not a collage. This is not a collage. It's just separate pictures that go into one file. Where's number 14? Okay, I see number 14. 8t squared plus 38t.
Wait, Mr. Rosenthal, we're still on 4.4, right?
Yeah, this is going to be like part 3 or part 4 of it. What did I submit yesterday? Did anybody go on YouTube yesterday and see? I think that was part 2 or 3. This might be even part 4. I don't know. But it's okay because we're really like going deep into, you know, we're tearing apart quadratic. So you guys, over the summer, when you get back in Algebra 2, I really hope that you're masters of the quadratic. So you're ready to go into conic sections right away. Okay? All right. And I'll communicate that with whoever your next teacher is. I'm going to meet with them. I'm going to let them know what you guys did. All right? But that means you better know it, because if I tell your next teacher what we did, they're going to assume you know it. So you guys cannot be lackadaisical right now. You're going to feel it. You're going to feel it pretty bad, or badly, right, sir? You're going to feel it badly.
Yes.
When you come in next year, if that teacher starts to zoom through, no pun intended. Hopefully your teacher's not zooming through. Okay, here we go. So the first thing you're going to do here is you're going to take out any common factors. So a 2. when it's still a polynomial like that, or a trinomial, I like the brackets, because then you're going to try to factor that into two groups that are going to be in parentheses. So having that foresight, this is a good thing to do. Put a bracket. Doesn't matter. You can have parentheses outside of parentheses. Is not illegal. Okay, 4
Mr.
squared plus 19t minus 5. And this is not this is a perfect square, but that is not. So you go ahead and ditch that whole trying to test, and you move right on to trying to find factors of -20 from the 4 times the -5 that add up to 19, which is no problem. It's going to be the -1 and 20.
Mr. Rosenthal, couldn't you factor this with the normal method?
Yeah, you could just go right to it now. But when you do, your two groups are going to have common factors that you're going to need to pull out, or one of them will, one or both. So if you pull it out now, then when you get your final two groups, two factors that are groups, they will not need to be factored further. And it's easier just to pull out something in common at the beginning, in my opinion. Okay, all right, so this will be 4t squared minus 1t plus 20t. Got that here. And I'm just splitting the 19 into 2 pieces so that I can share that 1 amongst 2 so that I could factor in groups. It's called factoring by grouping. Okay, always copy this 2 down, is what I was telling you yesterday, so you don't lose it. Students lose the 2. They lose this factor. When they pull it out at the beginning, by the time the problem is done, it's gone, because they just forgot to include it, and they get the problem wrong. Okay, so what's in common here is a t. So you just get 4t minus 1. Plus, I use that sign, take a 5 out, and copy the 4t minus 1, and check it. 20t, -5, checks out. And then finally, I don't need this bracket anymore because I'm going to put it in, the common is 4t minus 1. The not common is t plus 5.
Mr. Rosenthal, when I was factoring it with the original one, I got 8t minus 2 times t plus 5,
exactly.
which is 2 times 4t minus 1.
Yeah.
But wait,
you would pull it out. So you would get down to this point and you would have to pull the 2 out at the end. I pulled the 2 out at the beginning, pulled it out at the end. Doesn't matter.
So wait,
Doesn't matter.
We have to pull out the 2 either way. Because that wouldn't be the simplest form. Yeah.
It wouldn't be fully factored. It's not simplest form. Simplest form, I think, is the opposite. It's when there are no more. Simplest form is when you have less parts. Factoring.
So can you just leave 2 like that?
Fewer parts.
Who
You must leave
leaves?
2 like that. This is fully factored.
Oh, but when you're simplifying a fraction, you pull out common factors of the numerator and the denominator.
You're pulling them out, but you're dividing them out. It's different. I'm not dividing it out. It's still there. Okay. All right. I'd like to move on. Stay for office hours if you want to come back to these. But guess what? The problems we're going to do, you're going to need to know how to do this to do it. So you're going to get practice while doing the next set of problems. Zig, are you there?
Yeah.
My wife wants me to tell your mom that she loves the masks and wants to know a tutorial on how to make them herself. Just saying.
Okay. I'll tell my mom that.
No pressure, but we love them. Okay, did you guys see these? Oh no, this is the new thing. Okay, solving quadratic equations. Okay, so we learned the whole point of factoring is so that we can use it for one of our parabola problems, right? So solving a quadratic. Solving a quadratic is really finding the x-intercepts or the roots. It's finding out. So if you look at the standard equation, so let me come away from this for just a second here. If we go to the standard equation, you have y and x. X and y are coordinates on a coordinate plane, right? And we'll go back to the definition of a parabola. It's all the points in a plane equidistant from a point and a line. All right, so it gives you this. All right, later on we'll talk about that as the focus, and this is the directrix. We're going to give these things names.
That would be the geometric definition, right?
Yeah, well, I don't know what the reason is. I don't know if one's geometric and the other, I don't know that. But I know that these are names that we're going to work with to further our understanding of parabolas. So they're, even as much as we feel like we've torn this all apart, I guess that's what you're saying. Algebraically, yes, we've torn it apart. So maybe you're saying, let's tear it apart geometrically. I don't know. Is that what you mean? Or are you referring to some name that you've seen it referred to as? I don't know. Doesn't matter. Okay, so here's your parabola. All of these points are different xy's. They're different xy coordinates. A, B, and C are components that create transformation. A being, is it turned right side up or down? Is it steep? Is it flat? Okay. B is gonna be a shifter, a slider. C is always gonna slide up and down. B is gonna actually affect both left, right, and up, down. Right? If I adjust B, you might see the parabola do this motion. So I recommend you go into Desmos in all of the forms. You will learn what changing B does. If you leave A alone and C alone and you just change B and you make this equation in Desmos, you'll see what it does and you can break that apart yourself. We don't have time to do that. Okay? It'll stall things a little bit longer. Okay, but you can do that if you want to really investigate what changes. But then when you do vertex form or you do intercept form and you change the sliders and you start sliding them around, you'll see other things happening and you'll make connections. I did that with a pre-algebra student that's asking about parabolas. We were on Desmos doing that, and I was picking up things that I wasn't aware of. So I think that's a good task if you want to do that. Put all these different types of forms in and start sliding things around and you'll see what happens. But now, what are we saying here? We're saying that when y is 0, you must be located somewhere. When y is 0, you must be located where?
On the x-axis. No, yes.
You have no choice. Can anybody give me a counterexample of where a coordinate has a y value of 0 and is not on the x-axis?
You can't really do that.
No.
0, 0, 1, 0, 2, 0, 3, 0, negative a million, 0. Whenever the y value is 0, you are on the x-axis. That means if once I do that, you really need to understand what that means. You are now saying, I want to know what the parabola looks like as the x-axis intersects it. So here, let's say that that's the x-axis. Okay? You are not any longer looking at the entire parabola anymore. Once you make that 0, you're looking only at this kind of, it's almost like a cross section. You're only looking at the parabola. Let's say that you're a one-dimensional being and you're traveling along a dimension. You cannot perceive anything above or below this dimension. Have you guys seen Carl Sagan's Flatland?
No, but I have read part of the book.
Oh my gosh, I have to show you the video. Okay, I might, because it's Friday, I might stop this a little early so that we could all watch that together.
The book is interesting too.
This is only like a 10, 15 minute, and it's a really neat thing. It's having to do kind of what I'm talking about. Imagine yourself as a one-dimensional being. Nothing outside of this axis here exists. What would you be able to see if you were a point and your point was moving along that axis? Well,
only another point.
Let's say that you see nothing unless something comes across your dimension. This parabola is crossing through our dimension that we're traveling through as we travel this way across that x-axis. Well, what you're going to see is not the rest of the parabola. You're only going to see a point and another point, and you won't know anything about them. You'll just see, oh, here's a point, here's a number line here. You'll see it as a point. Oh, I just went past a point. I just experienced a point. And then later on, you experience another point. Okay? That's the experience. So if somebody were to come down out of 2D land or 3D land or our space-time land, 4D land, and come down and interact with this point, the point wouldn't see us, but maybe let's say it could hear us, and it sounds like a voice coming from the ether, and we lay this parabola down on top of them and try to explain to them what it actually looks like. They won't be able to understand what you're talking about. So anyway, getting a little abstract there. All right, so when we're doing this equation solving, I want you to know we're talking about those two parts of the parabola only once you set that equal to 0. Okay? Now, what we know about them from vertex form is one of these is the P, the other one is the Q, and the axis of symmetry is going to be the average. It's going to go through the midpoint. So x equals whatever that midpoint value is the line, the vertical line that goes through the middle. The quadratic equation, this is the negative b over 2a also. That's what this is here, right? And then plus or minus the square root of b squared over, or minus 4ac over 2a is what you add to get to this other point here. And it's what you subtract to the same thing. So plus or minus the same thing gets you to those points. That's the connection to the quadratic formula. All right, so without further ado, let's do some. Go ahead and solve A and B, please. The best you know how with what you've been given coming into this course. I'll give you a minute.
What is zero product property?
The zero product property says that if 0 times any number is 0.
They seriously need a they seriously need a property for that?
Yeah, they do. Okay. All right. We've just been working on factoring. So it suggests that in a textbook, it's going to follow the same strategy and build one extra thing. So you shouldn't be thinking, what do I remember from a long time ago? No, what do you remember from 2 minutes ago before I went on my rant? What do you remember from 3, 4, 5 minutes ago that we just talked about that's going to help you with this new problem? That's kind of the way you think when you read a textbook. And that makes a textbook much easier to read. I never understood why people have such trouble with textbooks. They make natural progressions. And that's how I figured out that challenge problem, is by realizing, oh, that whatever the tools that I need to solve this must be somewhere in the section. I should not have to look throughout the book. It has to be somewhere in this section, and sure enough, it was. Okay, here we go. Negative 24 and 10. Okay, 1 and 24, 2 and 12. There we go. Negative 2 and 12. 3x squared minus 2x plus 12x minus 8 equals 0. All right, so x is in common. So I have 3x minus 2 plus 4 is in common, and I copy the 3x minus 2 and check it, equals 0. Don't forget to copy the equals 0 down, please. Don't just do all this and then add it at the end. I need you to be consistent. It's an equation. It's equal to 0 the whole time. This is 12x, this is negative 8, it checks out. Okay, so then 3x minus 2 times x plus 4 is equal to 0. What you've done is you've really taken standard form. When you factor it, you've moved it to intercept form. These are your intercepts. Okay?
Mr. Rosenthal,
Mm-hmm.
why do you keep figuring it out by grouping?
That's the way you do it. How else would you do it? I think however anybody else would claim that they're doing it differently would be, I would argue that they are doing it by grouping and don't realize it.
Oh.
How else would you factor that?
Yeah, never mind, because you need to factor out. So you can't.
All right, so now here's where the 0, somebody asked about, I think it was Joseph, it's obvious, the zero property. But actually, this is where students get confused. Let's call this group A times group B, and it has to equal 0. Does A have to be 0 in order to get 0?
No.
B could.
Okay, if A is 0, does B have to also be 0?
No.
No.
Because
Either one of them could be
Oh.
0.
could both of them be 0?
Yes.
Yes, that will happen when you have a square. When this group is the same as that group, then both of them are 0, and A is equal to B. Okay, then they're both 0. Okay, now because of that, what I can determine is if I can find a way to make this group 0 by making x a certain value that would make this group 0, even if plugging it in here, it didn't make this one 0, that would be okay. It would still multiply and get 0. So you will get one solution by making just this group 0. If you made instead this group 0 with a different value, then of course you would have to use whatever that -4 there, you would plug it in there, and here you would not get 0 anymore.
Visually,
But that's okay, because the 0 property of multiplication would make it 0 when you multiplied it. That's what's going to give you your two solutions. Okay, and that's why they mentioned that. Okay, so now little trick here. Cover this up.
Can you just do 3x equals -2?
3x equals -2, 3x equals +2. That's what I'm going to get right now. Here, watch this. Watch this. If you cover this up, you realize what has to be put here to -2 to get 0. 2. So whatever is underneath my hand has to have a value of 2. Right? So this 3x has to equal 2. Well, if 3 times x has to equal 2, think of the dimensional analysis kind of thinking. You would multiply by 2/3 and you would get a 2, right? So make a rule for yourself, all right? So if x is 2/3, I'll get a 2, then the 2 minus 2 will be 0, okay? And I'll get my 0. Well, so what it's always going to be, if you want to get this to be an algorithm, I know a lot of you just want the algorithm, you need the opposite of -2 to get a 0, right? You need a 0 pair. So think opposite of this divided by that to cancel it out. So +2/3, so x is +2/3. That will cancel out the 3, leaving you a +2, which is the opposite of that, and it will give you 0. Now, of course, 2/3 plus 4 is 4 2/3. You did not get a 0 here, but that's okay. 0 times 4 2/3 is still 0. But x over here could be -4, and over here you're going to get -12. You're going to get -14 here if x is -4. But here you'll get 0. And when you multiply -14 times 0, you'll get 0. Okay, so -4 is another solution. And then,
Mr. Osta?
and that is those are basically your P and your Q right there. Right? In any order. It doesn't matter which one's P and which one's Q. By the way, how do you find, let's do a little spiral review. Once you know what P and Q are, or your roots, how do you find the axis of symmetry?
Average between the two.
Yes, you average them out. So what is the average of -4 and 2/3? You would get -3 1/3 divided by 2, right? So that's -10/3 times 1/2, -5/3. So that's your axis of symmetry right there, -5/3. That's the x-coordinate of the vertex, wherever that vertex may be. That's the x-coordinate. If you want the y-coordinate, you can plug it back in, right? If I plug it back in here, what would I get? I'd get -7, and then here you would have another, you would get what, 2 1/3. So you get 2 1/3 times -7.
When you're solving it, you can like say or, right? It can be this or that.
You would get -49/3. So anyway, you could plug in this.
You say this and that.
Yeah, it's and, because it's representing the 2 points where the parabola intersects. The parabola doesn't intersect at one point or the other. It intersects at both points.
Anyways, that's pretty much like,
Yeah, if you think about it, you're asking
solutions.
where does the parabola intersect the x-axis?
That's an easier way to understand why one of
It
them is 0.
intersects the x-axis at this point and at that point, not at one or the other.
Well, that way it's easier to understand as well, because when you take 3x minus 2 times x plus 4 equals 0, you could say 3x minus 2 is one point where it intersects, and x plus 4 is the other point where it intersects, and you're solving for either point.
Well, 3x minus 2 is not where it intersects.
Where it intersects the x-axis.
It intersects the
It intersects the x-axis at x.
Yes, I know that, David. I was just saying that if you use that, you could say that 3x minus is solving for 3x minus 2
Solving,
would
yes.
find 1 point. Yes.
Okay.
Yeah.
Let me go to questions now. Any questions about this before we talk about B? I'll actually give you a little bit more time with B.
Mr. Ostal, could you share screen?
Not yet. I'm going to put B here, so you don't need me to share the screen. I'm going to put B back here. I just want to see if there's any questions for this one. Okay, let's see if you have what it takes. I'm going to put B up here now and see how you do. So B is 5p squared minus 16p plus 15 equals 4p minus 5. And so they've gone a step further here and said, let's try to change it a little bit and see if the students understand how to tweak it in the way that manipulate it so that you can solve it. Get it into a form that you can understand. Do that now, please. Take a minute. I'm going to clean the eraser. When I'm done cleaning the eraser, I'll start to work on the problem. Just so you know, I don't find this part of the lesson as entertaining. This is the how-to, and you know, you're really like examining. I mean, it's interesting, but it's, to me, it's really, I'm trying to get you to understand it so that we can use it. It's, to me, the reward is, did I know if I learned it, if I can actually apply it to a problem? So that's what my goal is for this, not just, can I teach you an algorithm for solving these things? I'm really not interested at all in that. All right, let me read some comments here. There's someone called, okay, that's fine. I know of that person. Oh, the video, okay, yes. I don't know if anybody's video is on. I don't see anybody's video on.
Video is on, but it's all black. I can't say anything.
Oh, but it's on?
Yeah.
Okay. I'm okay with that. Oh, okay, so it messes up the video, I see, okay. Miss Almanza, if you could undo your video, stop video, please. Thank you so much. Thank you. Okay, perfect. Okay, let's start working on this problem. All right, so here we go. I think you knew what to do. What were you trying to do? What's your first thing that you think of when you're looking at this problem?
Zero. Equal to 0.
Yeah, you got to get it equal to 0. And so you can either move everything over here to the right side, or you can move what's on the right side to the left side. Typically, I will move it so that my leading coefficient is not negative, by the way.
There's only one way.
By the way, I ran into this problem when I was speaking with that other student. Let me do an aside real quickly. Watch this. If I have ax squared plus bx plus c is equal to 0, and I subtract everything onto the other side, does that mean my parabola is now going to be upside down? Because a is now negative.
No, there would be no parabola because it's not a graph. Is equal to 0 is not a graph, it's just points.
Very good. Wow, you caught that very quickly. As soon as you make that 0, remember, you're on that one-dimensional land where you're only discussing those 2 points. There is no parabola anymore is exactly right. Once you set that equal to 0, you're trying to find either no point, it could be no point where a graph intersects the x-axis. It could be one location if it touches in one place, if it's tangent, or 2 locations, okay? All right.
This is actually a perfect square. If
So
you
when that's
factor-
0, you could fool yourself into thinking, oh, did that flip over? No, it doesn't flip it over, okay? All right, so now, let's go ahead and do it. Let's subtract 4p on both sides and add 5. Okay, so 5p squared, subtract 4p, I have minus 20p now. Add 5 to get 20, and that's 0, and there's something in common. Now watch this. Instead of factoring out what's in common, now that this is not a parabola anymore, I have a 0 on the other side. I can divide both sides by whatever I want, and the 0 will stay there, as long as it's not 0. So divide out of 5. Don't factor out of 5. Divide out of 5. Somebody's going to go back and ask, how did I get to this step? I'm dividing everything by 5. And 0 divided by 5 is 5. Now, this,
You mean it's 0,
David,
Mr.
you gotta
Osta?
reset it.
what?
You mean it's 0, Mr. Osta? I
I
said
need it 0.
divided.
I said something else. What did I say, 5 or something? Okay,
Yes.
this is a perfect square. This is a perfect square. The square root of this is p. The square root of that is 2. 2 times p times 2 is 4p. This is p minus 2 squared. This is one of those situations where it touches only once, and it touches at p is 2.
It would also be the same if you had 5 on the edge. I know you just divided 5 out, but if you factored 5 out, it'd still be the same because 0 times 5 times whatever a number.
That's right. If you have a 5 still out there, yes. If you have a 5 factored out of this, 5 times p minus 2 squared. Then in order to get a 0, the 5 doesn't matter. Whatever this, making this 0 is what's going to make it 0. The 5
Wait,
can't get, the 5 will never get you to the 0. The 5 itself will never get you to 0. It's got to be what's happening in here.
He didn't want to keep writing the 5 over and over again.
Any questions about this problem?
Couldn't you just divide by 5p squared minus 20p plus 20 in both sides?
Yeah,
So
and
then-
you get 1 is equal to 0.
So when you have something equal to 0, you can do really funny things to equations to manipulate them to get weird answers. All right? What would you get? If you divide this by itself,
1 equals 0.
yeah, you're going to get 1 equals 0. And that's because what 0 basically destroyed your number. 0 is like a black hole that, everything gets sucked into 0 and doesn't come out again.
It looks like a black hole except when you write it in
That's an
orange.
interesting concept. Okay, so anyway, we're going to move on. Yes, question.
How did you get from p minus 2 squared to p equals 2?
What makes this whole thing equal to 0? What would p have to be to create a 0 on the right-hand side of the equation? P would have to equal 2 in value. Okay? All right, I'm going to go ahead and share screen, and we're going to move along.
Wait, can I ask you a question really quickly?
Yeah, you can. And look, you can see how they did it. They did
So
it.
slightly confused as to why it's no longer a parabola.
It's not that it's not a parabola. It's that once you say y is equal to 0, you're examining only those locations. Remember, x and y's could be any location along the parabola. Once you say what the y value is, you're only talking about specific points on the parabola where the y coordinate is 0. you're discussing specific locations. And specifically when y is 0, you're talking about what point is on the parabola and on the x-axis at the same time. So those are called the x-intercepts, or the roots.
So on the x-axis, 1 equals 0. Okay, good to know.
I don't know. I just feel like sharing some other things with you guys instead
Metallic hydrogen.
of just moving forward. But you know what? I want to move forward. So I don't know. Maybe I'll cave into that idea later.
I sent you an interesting link.
Okay, here we go. Let's see if you guys can figure out this problem. Yes, thank you for the interesting link. Go ahead and try this quilt problem. I'm going to read it out loud in just a second. Okay, you have made a rectangular quilt that is 5 feet by 4 feet. You want to use the remaining 10 square feet of fabric to add a decorative border of uniform width. That means, what does that mean, uniform width?
The same width all around.
Yeah, the same width all around. That's important. So you can read right over that word uniform and not understand what they mean by that. It means that it's the same width all the way. You have to use X amount of extra width all the way around. So you're going to add that uniform width to the quilt all the way around. What should the width of the quilt's border be? So basically, what is X? I don't think that this is too bad. They're kind of telling you, they shouldn't tell you 4 plus 2x. That should have been what you had to come up with. So in the homework, when you do the homework, you're right. It's because that this is an example problem.
Oh no, you're on the solutions page, Mr. Rosenthal. I'm sorry to interrupt, but you're on the solutions page. That's why it's showing.
No, the solution.
The solution is below.
The solution is always below it.
Yeah, the solution's always below.
Yes, but well, actually, it's not always below. Before you get to the solutions page, the problem's written on the page before, and that's where it's not. And that's where there is no hint.
I think the problem was originally written. This was the only offering that I was given. This is it. This is how they gave the problem.
Really?
Yeah.
No, that's not how it was with the go-kart problem. The problem was on
but that's a different problem. So the book may not be perfectly consistent without let's see. Oh, I gotta unshare the screen for a second.
Actually, someone, it was the same as the go-kart problem.
Look, that's how they give the problem. They only give one picture in the book. So that's what they give you.
Problem in cut off the pay problem in the go-kart problem, and then he made the solution on the next page.
Right,
so,
I did that. Yes. Okay. Okay, look. So listen, I'm just telling you that 4 plus 2x and 5 plus 2x will not be given to you in most problems. So they're telling you how to do this type of problem. You would just have the 4 by 5 information.
It's
right?
an example problem. That's why the solution's under.
Mm-hmm. So, okay, so you have the 4 by 5. All right, that's what you're given. You're given that you have a remaining 10 square feet to use, right? So what you're going to have to do is you're going to have to say the quilt plus 10 extra square feet is going to give you the area of the final quilt with the border. All right, so how many square feet is the quilt? 5 by 4. 20, right? The quilt that you see in the picture is 20 square feet because it's 4 by 5. All right, and then you have 10 square feet extra for the border. So it's just 20 plus 10, it's 30. So your equation has to be equal to 30. Your expression is equal to 30. Now, what is your expression? It's the quilt with a border added to opposite sides, right? So it's 4 plus 2x times 5 plus 2x. And this is very similar to that other problem we were doing where we were expanding the parking lot, you know? Okay, so this is what you should have. The new length and width of the quilt, length times width or base times height gives you area. The new area has to be the old area plus the extra 10. That's where I got the 30. Okay, and then we're going to, this is not vertex. This would be nice if it was already in vertex form, but it's not because that's not 0. All right, and it would be nice if I could just subtract 30 and it was in vertex form, but vertex form doesn't have a plus k on the end. There's no plus k on the end of vertex form. Okay, so you have to multiply it out, let the 30 fuse with your information, and then basically put it back. Kind of annoying, but that's what it is.
I did 4x squared plus 18x minus 10.
So I have 8x and 10x, so 18x, and then I'm gonna have plus 20. And then I'm gonna have subtract the 30. You get that?
I did it in a way that got me the blue equation immediately.
Great. Okay, there's a 2 that goes into all of these that I'm going to divide out, not factor out. You could factor and then divide. I'm just going to straight divide it out. Okay, the division property of equality. And 0 divided by 2 is 0. Okay, and then I have negative 10 because 2 times the negative 5, and then the 9. And 1 times 10, so negative 1 times positive 10. Rewrite. Let me go a different color now. 2x squared minus 1x plus 10x minus 5 equals 0. Now I'm going to go ahead and factor by grouping. What have I not used? Okay, pink, black. Okay, so x, so 2x minus 1 plus, use that sign, 5 is in common, 2x minus 1, I copied from there, check it, 10x, yes, negative 5, yes. Okay, what's in common is the 2x minus 1. What's not in common is the x plus 5. And we are back to intercept form. Okay, and maybe I'll go back to orange again. Oh, I have not used purple. Okay, so remember what I said? Opposite of the minus 1 is positive 1 over 2. So x is equal to 1/2, or x is equal to negative 5 over here. Now in the context of the problem, we're talking about an actual quilt. You can't add negative 5 to the quilt. So this is an extraneous solution, all right? And if this problem is in feet, then you're gonna add 1/2 foot border to the quilt. That's what this is. So x is gonna be 1/2 foot.
6 inches.
Yeah, 6-inch border. Okay, questions about this problem?
Here's how I did it. So, well, I did it the same way, except so you have the 4 corners, which are x squared area, and then you have each of the rectangles, so that's 5x, 4x, 5x, and 4x, so 18x.
Okay.
And then and so I just used the border, not the entire quilt.
Thank you. Anybody have any questions about this?
Actually, I believe I might have used. I did it differently in the initial stage as well. I didn't do it equals 30. I did 4 plus 2x times 5 plus 2x minus 20 equals 10, because we want the area around the sides to be 10. So 20 would be the area of the interior.
Minus 20 equals 10?
But then
minus 20 equals 10?
Yeah,
And
that's
when
what
you
he said.
subtract 10, you're going to get minus 30.
Well, when
No.
I added the 20 to both sides, which brought it back to what you were doing, which was 4 plus 2x times 5 plus 2x equals 30.
Okay, I missed what you did. I don't understand what you did. What did you do?
He didn't multiply out the binomials yet.
Oh, so you...
Well, actually, I did multiply out the binomials. I just started off with a different equation. I did 4 plus 2x times 5 plus 2x minus 20 equals 10.
Minus 20 equals 10. Oh, right. So then adding... Okay, got it. That's fine.
Yes.
All right. We're going to move on. all right, because we're starting to run low on time, and I really wanted to do some extra stuff that was interesting. So I don't know if I'll have time for our Carl Sagan one. Okay, there's our, what form is that? Quick.
Intercept form.
Intercept form. There's the P and the Q. There's no K added on at the end, right? And what's the P plus Q over 2 is average.
Symmetry.
It's averaging your P and Q, which P and Q are your roots, right? A is your steepness. It's whether it's facing up or down, okay? But so that's, they're just going to go and talk about doing it this way. So if they're going to mention that, guess what, this word problem, see, that's the thing that is it's not an advantage in the real world. In the real world, no one's going to tell you that this is the problem you get is going to come from a specific section in a math book so that you are suggested a method for solving it. No one's going to suggest these methods. These things have to be understood, and it'll have to occur to you without this support. Okay, that's what a test is all about. Even then, you know it's from that chapter. So even that's not really fair. Okay, that's why a final exam is good. Okay, but even that's not enough because it's from that year of learning. You know everything on there is going to be from that year of learning, right? And you can keep doing that. But anyway, go ahead and read that and try to do this problem. I think this might be the last problem.
I guess there's no substitute for the real world, huh, Mr. Rosenthal?
I love that. That's wisdom right there. Okay, a monthly teen magazine has 28,000 subscribers. When it charges $10 per annual subscription. For each $1 increase in price, the magazine loses about 2,000 subscribers. How much should the magazine charge to maximize annual revenue?
I can't believe at $1 they lose that many subscribers.
Well, that when you study economics, when you raise, so there's something called elasticity. All right, if a good is elastic versus inelastic, then changing the price, a good will be sensitive or not sensitive to price changes depending on its elasticity. Some goods are extremely sensitive to price changes. So a penny could affect the quantity sold and produced. All right, whereas other items like gasoline, you can change the price a lot, and a lot of people, people need gas to get to where they're going. So, but it still will have some effect, but not as much. See what I mean? So anyway, it just really depends.
I mean, the last thing this case needs is a loose cannon. She needs someone like you, a reliable.
Daniel, why are you watching?
Hey,
Gordon Ramsay?
let's not talk about it.
What do you think of that British accent?
Hey, you guys, I need you to focus on getting an equation that's going to help you do this.
Wait, what was it anyway?
You guys, I don't want to talk about it.
Oh, I already got the equation.
You can chat and you can text on the side, but right now we're going to focus on this problem. Okay, you got to try to wrap your head around, how do I get this into a quadratic? And they're suggesting that this form up here is used, this intercept form. Okay. Anybody have an idea of how to set this up?
Y is gonna be Y is gonna be the amount of annual revenue.
Yeah, that's a good place to start, everybody. For those of you totally stuck, go to what Y means. So when you're talking about maximizing annual revenue, Y is the item that you're trying to maximize. Okay, so your annual revenue is Y. So start a Y equals. That's how I would start this. Understand what this is. This is annual revenue.
Or you could do annual revenue as a function of the price increase. So f of n equals x plus n times 28,000 minus 2,000 n.
Great. You can make Y a function so that you're telling yourself, okay, it's going to depend on whatever. What is it going to depend on here? Subscriptions, right? It's no, it's going to depend on this price that can change, right? Changing the price is what changes your subscriptions. You're trying to not maximize subscriptions. That's important. If you're thinking I'm trying to get the most subscriptions, that's not what you're trying to do. You're trying to maximize revenue, because if you want to maximize subscriptions, you might think I'll just make it free, right? Why not just make it free, right? By the way, that might not maximize subscriptions. Making it free, when something's free, the value that people have for that personally, they might feel it's free, it doesn't have much value to it.
Yeah, it's
Putting
like
a price, people have this illusion that there now is value to it, and they value it because of that.
it's like
So what is
predictably irrational.
So tell me, how does a magazine make money? It's going to be the number of subscriptions times what?
Times the price.
Times the price. So if you have a number of subscriptions, right, and it's charging $10 per annual subscription, you can say 10 times the amount of $10 times the subscription, right? Wait a minute. $10 per annual subscription. Oh, then you can actually find out what that is right away, right? $10 per subscription, 28,000 subscribers, you just multiply, it's $280,000. So that's your starting point, right? You're starting at $280,000. From there, you're gonna, for each $1 increase in price. So now what I'm gonna do with that is I can now talk about increasing the price. But so this is my why. This is my initial revenue that I'm starting with when I don't increase any amount of money. So it looks like X is going to be the amount of money I increase, right? Yes or no?
Yes. No. Yes, that would be true. And so, you could do either the standard method for finding maximum and minimum. I just use the derivative.
Okay, can I tell my equation?
Yeah, give me your equation.
Okay, y equals, open parentheses, 28,000 minus 2,000x, close parentheses, times
1,000 minus
2,000x,
that's interesting.
close parentheses, open parentheses, x plus 10, close parentheses.
Yeah, that's what I did too.
Okay, explain why. What is this showing?
Okay, so the first group of parentheses is the number of subscribers.
Hold on. Okay, so hold on. Let me stop this. And okay, so this is what David is proposing. Go ahead.
The first set of parentheses is the number of subscribers, and so x is the amount that we increase the price, and so for every dollar that we increase it, 2,000 people are gonna stop. So 2,000x is going to be the number of subscribers that are no longer subscribed. And so we subtract that from 28,000.
Okay, so if X is $1, then I lose 2,000 subscribers.
Yeah.
Which comes off of
26,000.
Which comes off of my 28,000.
Yes.
If X is $2, then you're going to lose 4,000 subscribers, which will come off of your 28,000.
Yes.
That makes sense to me.
The second set of parentheses is the overall price. You start at $10 and then you increase a certain amount of dollars.
Right. So your initial charge was $10 plus whatever X is in dollars. That adds to the price, which means you're going to make more money off of each subscription. So this represents the amount of money you're making off the subscriptions. This represents the amount of subscriptions.
So it's revenue equals subscription. So revenue equals number of subscribers multiplied by price per subscriber.
Price per subscription. Price per sub. Right? So there you have it. And that makes sense to me.
That's a general formula for most of these types of problems. You could solve the go-kart one like that too.
Yep. Now this was very tricky to try to think about this. All right. So now it's just a matter of solving it. Okay, and this will probably take us to the end of class.
You could use derivatives just to finish it off instantaneously. All you have to do is simplify the expression and just find the derivative.
Okay, so what Søren is saying is going back to where is the maximum or minimum point? It's when the tangent, so if I have this parabola here, there's a slope. At any point, there's an instantaneous rate of change. It's at the maximum point, that tangent line, which is the slope of it, is the derivative. When the slope is 0, is at a maximum or a minimum point. So if we're trying to find the maximum profit here, and this is our profit function, then just taking the derivative of the function and setting it equal to 0, because the derivative is the slope. So solving it with calculus is a more advanced strategy, which I would recommend if you already know how to do it. Otherwise, we need to find it using vertex, finding the vertex. The vertex is at P plus, it's the average of P and Q. All right? So what I can do here is I can, this is not in fully factored form because I can factor out a 2,000 here. So what I would recommend you do is maybe flip these around first so that you get your negative 2,000 x plus 28,000. And this is good, x plus 10. Okay. All I did was flip that around. Take out a negative 2,000. And that's going to be your A. All right. Then that leaves me x minus, because you're taking out a minus, that's going to be negative times negative, right? And that's going to leave you what? 14? 2,000 times 14 is 28,000. And I'm not going to multiply it out, which saves you, you know, you might be saying, that was close, I didn't want to multiply those numbers. You don't need to. This is why they're suggesting the intercept form, because you're looking for the maximum or minimum, right? Well, P is 14, Q is negative 10. Those are the roots. That's when Y is 0. Okay? Well, we don't want to know when the revenue is 0. That's not what we want to know. All right? But we can still use P and Q, right, on a graph. What does that look like on a graph? Here's 14 over here. Here's negative 10 over here. The parabola is doing this. Okay? All right? This is revenue. Y is revenue. X is going to be the amount of money increase and how it affects your revenue. Okay? We're trying to find this. So far, you only know that. How do you find that? Find the midpoint. Average them. 14 plus negative 10 is 4, divided by 2 is 2. So x equals 2 is the axis equation for the axis of symmetry. I know the x coordinate here is 2 because it's on that axis of symmetry. Okay, plug 2 in anywhere you want. Plug it in here. You plug 2 in here for x, you get negative 12 times 12 is negative 144 times negative 2,000. So positive 144 times 2,000.
288,000.
288,000, yeah.
And that is going to be the y coordinate, which on the y-axis, that's your revenue. That's your maximum revenue right there.
If you multiplied it out, you would be able to factor out an 8,000. It's very satisfying.
The most money you can make. Now, by the way, what was the x coordinate? X is
2.
what? It's the dollar amount you're going to
just increase $2.
Right, to maximize your profit,
you should make it $12.
You should increase the price of your magazine subscription by $2, and you know what your revenue is going to be. It's going to be $288,000.
If you lose exactly 2,000 subscribers for each dollar increase.
Okay. Now, in this form, this might have been faster than multiplying it out, expanding it, and taking the derivative. This actually might have been faster.
Not really, because
let's try that out. Let's multiply it out and do that.
There's a trick Mr. Knaus used to multiply out these, and so that's what I was using.
10x and minus 14x is minus 4x, minus 140, and I'm going to multiply by negative 2,000. So negative 2,000 x squared plus 8,000 x plus 200, that's times -2 is plus
180,000.
280,000.
It's very satisfying to factor out an 8,000 here.
Now, this is how you take the derivative. So this is that alternate strategy that those of you are, are hungry to learn.
Negative b over 2a.
Remember what the derivative is. It's a slope. So it's delta y with respect to how x is changing, right? So we call that delta y over delta x is equal to, and then, so that's what happens on this side. I want to know what, not y, I want to know what the change in y with respect to the change in x is. Well, you'll learn in calculus the proof for why this works, but I already gave you the algorithm.
Negative b over 2.
Drop the exponent down, you get negative 4,000 x, because the exponent loses 1, so it becomes x to the 1, plus this 1 drops down, you get times 8,000. X to the 0 is gone, and the constant is gone. That's the slope. At any given x coordinate along the parabola, that will give you the slope. So if I want to find out what the slope is at x is 0, if I want to find out what the slope is at x is equal to 1, what will the slope be? I'll plug in x is 1. If I want to
negative b over 2a.
along this curve, if I want to know the slope at this x value, then you'll go to that x value, you'll go up to the parabola and say, what is the slope right there? By plugging in that x value, you get it. But what I want to know is, what is the slope there? Well, I already know what the slope is going to be there. It's going to be 0. That means I can set this, I can plug in 0 for the slope.
X has to be 2.
And solve it. And this is using calculus to solve the same problem. So you add 4,000x to both sides. So calculus doesn't seem so bad once you really know your algebra. X equals 2, exactly.
Well, yeah, it takes longer if you explain
Your
the process.
x is
Yeah, but
invisible.
either way.
Your x is invisible.
Dismissed. Oh, wait, no. Sorry. Let me give you the homework. The homework is,
I already did the
there
homework.
was some guided practice. It's 4.4 evens. Homework is assigned. 4.4
When is it due?
even. It's
Is
due
it
next
due
Friday.
today?
Wait, it's not due tomorrow?
No,
Oh, of course not.
Yeah.
it's due next Friday.
Oh wait, no, today's Friday.
Yeah. All right.
Today's
so
Friday. I forgot. Okay.
Homework is 4.4. This lesson, it's not in the homework folder. I still am having students come, and you know what I say to those students is, are you attending our Zoom lessons? Because if you're attending the Zoom lessons, you know exactly what's going on. People that don't know what's going on, it's because they're not attending the Zoom lessons, nor are they watching the full videos later. Because I think it's clear the homework is not in that homework folder. That was only the first one. I would delete it, but then there are people that didn't do it and will need to access it still. All your homework is in the lesson. This lesson, I got it from Schoology. I input it into Schoology, and the homework is here. Okay, so look, I'll show you. Here's our lesson that we're doing. And at the end of the lesson, guess what?
Put 4.1 into the Zoom
There's
lessons
homework.
folder and then delete the Zoom homework folder.
Put it into the other folder. Yeah.
Yeah, just copy it and put it in there.
That's a good idea. But I would like, it's just more. It would take me not that long. It's just another one of those things where I'm doing it for the student. I feel like students are their brain power or their brain capacity is atrophying because I keep doing these small little tasks that you guys have to do some of this stuff yourself.
Yeah.
Not you, but students that are having trouble with that. It's because they're relying on people to hand feed them everything, and you can't. You just.
Thank you, Mr. Rosenthal.
Oh, you're welcome. Have a great weekend. I'm on office hours now. Homework has been assigned. I'll have to put that in. Let me write myself a note. And I'll take any questions now.
Did you read the metallic hydrogen paper thing?
The one you just sent me now.
The one I sent you last night.
Oh, last night?
What is it? What is?
Oh yeah, I wanted to send it to you.
Wait, Mr. Rosenthal.
Here, Soren. I can email it to you, okay?
Yes, somebody's asking me a
Just wait.
question.
Wait, David, send it to our group chat.
Yeah, I was asking a question.
Oh,
Is this
okay.
is this the start of algebra 2, or is it just a continuation of old algebra? Like, are we going to review this again in the next year?
I'm going to speak with your teacher. Now, if you go, I mean, assuming you're coming back to our school, right?
Mhm.
Some people are leaving, but assuming you're coming back to us, I'm going to be very involved with who your next teacher is going to be. And they're going to know what you guys did, and they'll be able to include that. And they'll be able to use that to their advantage so that you're not going to do this all over again. Maybe they can just brush up and make sure you know it and move on quickly.
So, Mr. Rosenthal?
So this is not a continuation of algebra 1, because I felt like a lot of the stuff is I already learned in the second semester of algebra 1.
That's the whole first semester of algebra 2 is algebra 1.
Oh yeah, right.
Mr.
That's how
Rosenthal?
traditionally algebra 2 is taught that way, because you take geometry, and because students are a year or more out from having done it, they usually need all that review, which brings us back to the purpose of what we're doing now. I'm not just giving you algebra 1. I'm giving you a little bit more insight. And then I'm gonna add some more things to it. So you'll see some things added in. And then when you actually go into algebra 2, you're gonna be able to get past all this stuff much faster is the idea. But if too many students now are not taking this seriously because they feel like, oh, the geometry stuff is over, then there'll be too many people that need catch up, which will slow the whole class down. So hopefully everybody's taking this seriously.
Mr. Rosenthal, I have a question.
Sure.
So I am leaving Science Academy after this year.
Uh-huh.
And I'm most likely going to attempt to get into Algebra 2 trigonometry.
Uh-huh.
With what we've learned so far and finished in geometry, can I assume that I most likely would make it into that class?
I think so.
Okay.
And you never know. You know, when you get to a place, you might have had struggles, and all of a sudden something changes, and you're finding you're going to have, you know, success, or it could be the other way around. So there's no guarantees to things. But if you feel good about what we're learning and you feel like you're getting it, that's not enough, by the way. You have to actually prove it by doing problems and getting the right answer. And if you do that, you'll build some confidence there. And really, you just need to have some confidence. It can't be fake confidence. It's got to be real. In order to get real confidence, you have to have proven to yourself that you can actually do it by doing it. So by you doing problems, checking the answers and seeing, oh, I'm getting these right every time, consistently, 10 times, 20 times in a row, there's no problem that they can give me where I'm not getting it. And you know, you have these assignments that I'm giving you. That's what you should use these for, building your confidence. If you have that, I think that that's going to be huge for next year's determining whether you're successful or not.
Mr. Rosenthal, actually, I think you're right, because it would take a while to leave the bottle. Oh, it's a joke, because
Wait, say it.
I said it would take a long time to leave the bottle. It's a joke, because you said if there's so many students next year who need to catch up.
Oh, catch up, yes.
Yes.
Yeah.
Son, it's not funny if you have to explain the joke. You should have
Thank
said
you.
it back when he said ketchup.
Oh,
Well, I was going to, but he was talking. I didn't want to interrupt.
okay.
Thank you, Mr. Rosenthal. Have a good day. See you
Okay.
tomorrow.
I sent the link to you and
I wanted to show you
Daniel,
guys
okay?
on Friday the two things. I wanted to show you the video, and I wanted to show you what imaginary roots would look like and what they mean.
I think like the square root of -1.
I wanted to show you what that would look like on the graph, because
Parabola with imaginary roots, I think.
I could show you that, but you guys are leaving.
We don't have to.
I can stay on for another 10 minutes,
quickly.
15 minutes.
Check this out. Watch this. So imagine only that number line exists. Nothing else exists. We're back in one dimension.
Right.
Right? And you have those coordinates along the x-axis. Where is that if only the x-axis exists? Hello.
You
What?
can't
Oh, yeah,
describe
that's
it.
I.
Where is that? Here's 1, 2, 3, -1, -2, -3. Where is that
Oh,
located on the
at-
number line?
At my best guess, that's gonna be 1 something or other.
It's
It doesn't
nowhere
exist.
on the
It
number
doesn't
line.
exist on the number line. So
Yeah.
if you're a being that lives on X,
Thank you, the detective. I'm going to take
you
a
live.
Oh, that would be an imaginary root.
You can never see that point. It's imaginary to you. You can try to imagine something.
Like, what if there was a point up
abstractly.
there?
You can try to,
Absurd.
hold on. You can try to imagine something abstractly existing over there, but you can't see it. You can't perceive it. All right. So what we might do is we might create an imaginary dimension
You've been locked up.
called the I-axis, right?
Now you're free. You got mouse.
Where we can count maybe along that imaginary axis, although it's still in the reference frame of existing only on the x-axis, but it doesn't exist on the x-axis. Now, it does have some x component to it. You can see it's moved to the right of 0, right? So if I say it
Daniel, stop.
I can count here 1i, 2i, 3i, 4i, right, in along the imaginary dimension, right? And how I would label that point is I would say that it's
1, 2i.
1, actually, I'm going to add, as if I'm adding vectors, 1 plus 2i.
Oh, that would be a complex number in the form A
Yes.
plus BI.
Yes. 1 is the real component to it.
And the imaginary component is 2.
Yeah, so now how does that help us when you have, let me bump this over here, 1 plus 2i. If I have a parabola that does this,
It never touches the x-axis, but
you will still have some axis of symmetry, won't you?
yeah.
And this,
No.
this point will be located plus or minus some distance away from that axis of symmetry.
So on this parabola, all points are roots. If you can, there's no defining factor, so you can just make up where the roots are.
I don't think you can make up where the roots are. I think when you have a quadratic, or let's look at 1 plus 2i. What is 1 plus 2i? I squared is equal to negative
1.
Take the square root. I is equal to the square root of -1. Right? Now,
Square root of -4.
Let's put 2 back inside.
Square root of -4.
2 inside the radical is a 4, right? So then this will be 4 times -1, which is -4. Okay? So imagine if I had this. I did the quadratic equation, and I got this. And you said, oh, there's no real roots. But there are roots here.
But wouldn't that be 2
Wait a minute,
plus?
hold on. They're both up at 2i because they both have the same height, right? The 1 could be the axis of symmetry in your problem. In this case, it could be 2. So it would be, right? In this example, I have 2 plus 2i, right? So I didn't do anything with that real part, right? So 2 is where the axis, x equals 2 is the axis of symmetry.
And then plus root 4 or minus root 4 gets you left and right at 2i.
Now, I'm not sure if this is how that works, by the way, but I'm just saying that if you investigate this more, if I want to move horizontal, though, I need to show that I've moved horizontally. This is moving along the imaginary, right? Now, remember, when you're finding roots, you're only finding what's touching the x-axis in that dimension, right? The reason why you don't have real roots is because you're talking about points that actually exist. They just don't exist on the x-axis.
Wait, so wouldn't this mean... Okay, so wouldn't this be like 2 plus or minus 1 at root -4? Because that would be the y value. or the I value. And 2 plus or minus 1 is the X value of the roots.
I don't know. You'd have to examine that. Let's try to get, what would that look like? 2 plus or minus, what would that mean?
Well, I mean, well, that doesn't make sense because there's a real number line horizontally and an imaginary line vertically. You can't add horizontal and vertical, not really.
Well, with vectors you do, don't you?
Oh wait, no, that makes sense because okay, so actually wait, no, it would have to be 2.
Wouldn't
2
this
plus.
be adding 2 up and down?
Okay, but how about this? 2 plus or minus 1 plus plus root negative 4.
2 plus or minus what?
2 plus or minus 1 plus root for negative 4.
Yeah, but that's not how it turns out when you do the quadratic formula. You get something like this, right? Over 2a, right?
Yes. Mr. Oster, I was going to ask, how would you take the complex conjugate of multiple terms? If you multiply the two, if you not simplified, algebraically multiplied two complex numbers together, how would you take the complex conjugate?
Like that.
No, for instance, if you had in the general form a plus bi and x plus yi, just to specify different variables, and you want to prove that the complex conjugate of both of them multiplied together is the same as their complex conjugates multiplied together, which is basically the complex conjugate of the first times the second is the same as complex conjugate of first times complex conjugate of second. How would you prove that?
You want the product of this, and then you want the conjugates, the product of the conjugates. That's what you're saying?
Yes. How would you prove that the product of those, then conjugated, is the same as the product of their conjugates?
Expand them out and do both things and see if they come out the same.
Negative by times negative yi.
That's what I mean.
Is negative bi. Wait, negative 1 times negative 1 is positive 1. So bi times yi is by squared. I squared is negative 1. So
I have another class card on the screen, but let's just
all right.
Here. Hold on.
One last thing, Mr.
AYI plus BYI, no, BXI.
Plus BYI squared.
Yeah. And
minus
I squared.
So that would actually be minus BY.
-1, so yeah. So
how would you take the complex conjugate of that?
Wait, it's AX minus BY.
Okay, so you're
AYI plus BXY.
What is the conjugate of a polynomial that's not a binomial? Is that what you're saying?
Yes, that's what I'm saying, Mr. Oster.
I don't know. We'll have to look at that. We'll have to look
AY plus BX.
So all you need to do then is answer this. What is the conjugate of plus, what is the conjugate of this? If you can answer that, then you can answer that. So you should look into that. What's the?
Wait a minute. This is basically a trinomial if you simplify it. Well, actually, no, binomial because AX and BY are in the same.
Yeah, these are like terms, right?
AYI and BXI are like terms, and AX and negative BY are like terms.
You can call this AY plus BX I. Minus.
And negative BY and AX are.
That's real. That's real. And here is your imaginary part.
Oh, then you could easily do it.
Yeah, so I guess you could. So look at that. Okay, so then the conjugate would be AX minus BY minus AY plus BXI. There's the conjugate of that.
I see. Thank you, Mr. Oster. Have a good day. See you next week.
All right,
okay,
guys.
so and Daniel, I sent you the link.
Okay. All right, guys. Have a great weekend, okay?
Thank you, Mr. Oster. Have a good day. See you next week.
Bye, everyone.
Bye.
Weekend.
Thank you, Mr. Oster. Have a good day. See you next week.
Okay, bye.
Bye.